giving a few minutes to let everybody come in to online. So just bear with us. And we'll get started shortly. Morning, everyone. We're just taking a couple of minutes just to let everybody come into the Zoom, and we'll get started in a moment. Okay, I think we'll make a start. So, kia ora, everyone, and Dia Gwitha Corda. You're welcome to the State of the Science webinar series being run between the New Zealand Agricultural Greenhouse Gas Research Centre in partnership with the Teagasc Climate Centre in Ireland. My name is Sinead Leahy. I'm the Principal Scientist at the NZAGRC, and I'm delighted to have you in our audience today. This is the last of our webinars for 2024. But we do have a number of exciting ones planned for 2025. So please keep an eye on our socials and our website for more information as they pop up throughout the year. We'd be delighted if you continue to join us on this webinar series. But back to today. Today's webinar is all about peatlands and the challenges of managing soil carbon on agricultural peatlands, a really important topic for us here in New Zealand, but also equally for us in Ireland as well. We're very lucky and delighted actually to be joined by Carl Richards today, who is the head of the Teagasc Climate Change Centre. We're really excited to have him tune in tonight for us this morning here in New Zealand. So Carl will be your chair today, and he'll introduce you to our wonderful speakers and talk you through the session. So Carl, over to you, and Merry Christmas, everyone. Happy holidays.
Thank you, Sinead, and hello, everybody. So as Sinead said, I'm Carl Richards. I'm head of the Teagasc Climate Centre, and this centre focuses on the identification of technologies to reduce greenhouse gas emissions from both agriculture and land use. So just want a couple of reminders first. Reminder that you can ask questions using the Q&A tab, and do that as we go along, as the questions arise to you. But also keep an eye on the questions. If there's a question you particularly like, give it a thumbs up, because that will push up the priority list for questions. And the webinar is being recorded and will be available on the relevant websites within a week of this. And today we're going to hear from Professor Louis Schipper and Professor Owen Fenton as well in Teagasc. So firstly, we're going to start with Louis. So Louis is probably well known to our New Zealand friends. He's professor at Waikato University, where he investigates soil carbon and nitrogen cycling and how they can be manipulated to achieve improved environmental performance. He's been working over the last decade leading a team that's investigating changes in soil carbon stocks of pasture soil from paddock to national scale. And he leads a team on data and understanding. His team also has provided data and understanding that has been central to developing the national picture of New Zealand's carbon budget. Louis is going to start his presentation with a couple of slides, which gives an overview of peat soils in a global focus, as this is common to both of the presentations. So, Louis, if you could share your screen and begin your presentation. Now we can see that full screen. Right? Thanks, Louis.
Thank you very much. Yeah, thanks very much, Carl. Very much appreciate the opportunity. Kia ora, everybody back home. I'm actually visiting Ireland at the moment and very much enjoying myself and learning a lot about peat. As Carl said, I wanted to just start a little bit with a sort of a broader picture than just New Zealand and Ireland, perhaps, and think about the peats at a global scale. And so while it doesn't cover much of the Earth's surface, only 3% or so, the amount of carbon that is stored in peat soils is enormous. It's more than what is stored in all the forests combined. And so keeping that carbon in peat is incredibly important in terms of managing CO2 emissions to the atmosphere. Here's a map of the peat around the globe. You can see a lot up in the northern cold regions, but there's plenty of peat in other parts of the world as well, both in temperate and in tropical areas as well. Now, if you leave peat as it is, that's fine as a natural ecosystem. But if we want to be able to use it for food production and agriculture, we need to drain the peat itself. And that allows traffic and animals on the land. There's a variety of different peats shown down the bottom there. But this drainage also means that the water has been displaced and air can now get into that peat, carrying with it oxygen. Now, the reason that you have peat is because there is very little oxygen in a water-saturated environment, and that means that the organic matter stays there. When oxygen gets in, the microbes get active and they start to decompose that peat, which leads to a number of issues. Drained peat is a very large source then of greenhouse gas emissions because of that decomposition. Degraded peatlands emit about 4% of our global anthropogenic emissions. And a map there on the right-hand side there shows how those emissions vary across the globe relative to the amount of fossil fuel or greenhouse gas emissions that come from fossil fuels and cement. Now, some of those areas light up because they don't burn many fossil fuels. But what really this is showing is that the issue of greenhouse gas emissions from peat is a global kind of issue distributed all around the globe with varying amounts of impact to national greenhouse gas emissions. And if we want to know what these emissions really are, because they're not really that well understood, we need to know a couple of different things to determine the size of the emissions. But then if we're going to come up with any mitigation strategy, we also need to know what the emissions are. And to get at this total emission, we need to know the area of the different peat types and the way they are being used. And they are being used globally in very different ways. They formed under different climates. And so these peats can vary around the globe quite a lot. So we need to know the area of each of those types and uses. And then we need to know the emissions from each of those types. We have some general ideas, which is what is used for default emission factors for calculating national budgets. But really, we want to get better at that at individual national scales. And the pictures down here, down the bottom, are just some of the peats that I've had an opportunity to see. Iceland, Ireland, and New Zealand just in the last few months or so. They differ. So that's the sort of the big picture, if you like, at a global scale. I want to turn my attention now to Aotearoa, New Zealand, and the importance of managing these peatlands for soil carbon. I want to acknowledge my co-authors, Jack Pronger, Aaron Wall, Dave Campbell, and a number of others who will be acknowledged at the end, who have been very important in terms of making initial estimates of greenhouse gas emissions from peat in New Zealand, the funders down the bottom. So in peat, it's a smaller proportion than the globe, 1% of the land area of the mainland, concentrated in a couple of areas, mainly in the Waikato, which is in the centre of the North Island there, and down in the South Island, 20% in Southland. Not a very large area. Most of the work, I'd say, has been done in Waikato, and this is just a blow-up of that region. The areas in green are peat soils, quite deep in places, up to 14 metres of peat. The areas in the sort of reddish brown here now are the ones that remain as pristine peatlands. The other areas in green now are used for agriculture. So this is where most of the work has been done to date. What do they look like? And I found that this was actually relatively important after my visit so far in Ireland and Iceland. They do look very different on the surface. This is New Zealand. On the left-hand side there, you can see very intensive agriculture with dairying. You can see the herd in the middle there, very flat, ryegrass clover typically, drained relatively deeply, but intensively grazed by dairy cows predominantly. Now, we know that we now have some issues associated with the drainage of these peats. So you get subsidence of about 2 centimetres of peat height per year. So, you know, over 100 years, that's 2 meters of peat gone. And that leads to some issues with respect to infrastructure. You can see the dairy shed on the left has had to be repiled. So is the water tank on the right. And you can then also end up with more flooding than you might like to have. Because these peats are so deep, this shrinkage can go for decades and likely, potentially some areas, for centuries if we do not try and address these issues. The other issue that these peats have is that they are relatively large sources of greenhouse gas emissions. We've calculated using IPCC default values, the emissions of nearly 4 megatons of CO2 equivalent per year. That's about 6 to 7% of our net emissions at a national scale. The chart on the right-hand side there demonstrates the type of land uses that are on these peats. And you can see that the majority of the CO2 or greenhouse gases are coming from grazed pasture grass type systems. But the numbers are quite uncertain because the areas are not as well constrained as we'd like, and we are using default emission factors at present. The majority of these greenhouse gases that come from these peatlands turn out to be from CO2. So that is the decomposition of the peat that is there. There is a small contribution or smaller contribution from nitrous oxide and from methane during those decomposition processes, and DOC is dissolved carbon that gets lost. But the majority of this is as CO2, so the decomposition of the peat itself. And this does not include the animals on the land. So in other words, the methane or nitrous oxide emissions associated with the animals. You can then add in what are called peaty clay soils. So these might be the edges of bogs where the peat has retreated due to decomposition, or other areas where you've got this sort of highly organic mineral soil, which are classified as a peaty clay soil. When you add those in, and again used IPCC default emission values, you end up with about 11% of New Zealand greenhouse gas emissions coming from the combination of peat and peaty clay soils. But again, these numbers are uncertain. So I think it's a reasonable question to then ask, is these, or are these default values reasonable for making these calculations? We have a few studies or a few measurements, mainly in the Waikato, making measurements. Most of it came out of a program that Dave Campbell at the University of Waikato led, called Peatwise, in collaboration with European partners as well. The average value that Dave and other measurements have been made in the past give us similar numbers to the IPCC values that we used as defaults. So that's a good start, but not a lot of numbers. To be fair, that is poorly representative of other parts of the country, potentially like Southland, where it's going to be cooler, and same with the Chathams, also cooler, and probably also not Northland, where it'll be warmer again. So we need some better numbers to be certain about those default values or improve on those estimates. So what are we doing about this sort of data gap? We're working with our Irish colleagues here, as was mentioned at the beginning. We've got a program called MAPSTERS, Modelling and Measuring Agricultural Management on Peat Soils, with a modelling component that is trying to identify the best models and how they might work in New Zealand conditions to be able to predict the size of greenhouse gas emissions spatially. There will be a specific focus on the water table depth, and I'll come to that in a moment, but that seems to be the dominant driver of greenhouse gas emissions from peat. We'll be making measurements at 3 sites, a natural peatland that Dave Campbell has been running for about 12 years now, a deeply drained site that's been running a few years as well, and a recently installed site of shallower drained peat put in by Manaki Whenua, Landcare Research, Jack Prongers and Georgie Glover-Clark put in. Here's our partners in the project. So I'm from the University of Waikato on the top left, Trinity in Dublin, Chagas, Manaki Whenua and University College Dublin. Great to have that team to work with. We're also looking to expand our peat work through a future proposal or a plan of work with the New Zealand Agricultural Greenhouse Gas Research Centre with several questions, but one of the central ones is, can raising the water table, bringing it closer to the surface, decrease emissions? And there's on the right-hand side here, I'll just direct your attention here. This is effective water table depth. So this is deeper down in the soil, up to 1 metre down. And on the y-axis, you have emissions. And anything above this line here, where the red arrow is pointing, is carbon or greenhouse gas emissions up to the atmosphere. What we're trying to do is get down into this region here where the emissions are effectively zero, and that is quite shallow water tables. This line has been also tested in other parts of the world, so the Netherlands and Germany, and they don't get quite the same line, and there's probably very good reasons for that, and we need to determine that for New Zealand as well. To get at this, we're proposing that we install 4 other sites for measuring greenhouse gas exchange that sit between the deep site that's in the MAPSTERS program and in the shallow site from the MAPSTERS program to extend that range. Other work that we're hoping to do is measure the emissions from different types of crops that are on land. I've got a couple of examples there, maize and blueberries, to determine if and which land use has the lowest greenhouse gas emissions. It's likely that maize will probably have a higher one, but we need to sort of understand what the range of emissions might be, and we don't know what blueberries might be. The final bullet point there, polluter culture, is not necessarily that well known, but this is what is considered wet agriculture, and around the world people are trying to understand what that might look like. Could include the production of energy crops and other niche products. Lastly, within the work with NZAGRC, we're hoping to look at what happens when there is passive retirement of less productive land. So there are areas of peat soils that are not that profitable because the nutrient status is low or the water table is a bit high, and these are being effectively retired without active management. So you can see that on the left. And nicely, we went to see one of these sites, and on the right-hand side there, the plant that's in the foreground there, the sort of bright green one there, is Empedisma, and that is the main peat former in New Zealand, and that has recolonised parts of the site. So that's very encouraging, and who knows what the future of that site might look like, and whether, and hopefully there are reduced greenhouse gas emissions that we are interested in finding out. There have been a number of desktop exercises as well, led predominantly by Manaki Whenua. I'm just going to skip through these quickly. You can find these online if you want. Early on, what the potential management interventions to reduce subsidence and CO2 emissions in the Waikato for the Waikato Regional Council. Some work for MPI, looking at improving the inventory of drain peat soils, what we needed to do. Finding more what is called activity data, so in other words, where is or how much area are the different organic soils out there. Then you will be aware that last year there was some, I think it was last year, large fires on some peats, and they can release large amounts of CO2 as well. And so Manaki Whenua for Department of Conservation measured some of those, or calculated some of those emissions, and I note that there was a recent other fire at Whangamarino. And then just lastly here, a bit of a forward-looking plan for looking at what peatland management might look like in the Waikato in the future. So I'll just pretty much leave it there. The summary is that peat's only a small proportion of the land in New Zealand, but has a outsized release of greenhouse gases to the atmosphere, and more when you add peaty clay soils. The data is very uncertain, and we need to improve on that. Subsidence there is about 2 centimetres per year and will go on for decades to centuries. We have a couple of projects underway, MAPSTERS, which is an existing project with our Irish colleagues here, including modelling and measurement. And we have some planned work for NZAGRC on mitigation strategies, including water table and alternative land uses. Just want to acknowledge that this is a big team effort here of a wide range of skills that I very much appreciate working with, including our Irish partners that we are starting to become familiar with. So with that, I will hand back to Carl.
Thank you, Louis. That's a super overview of everything that's happening in New Zealand, and I suppose what's due to come as well. So we're going to move on now to the talk by Professor Owen Fenton, who's a Principal Research Officer at Teagasc Johnstown Castle, where he leads a team working specifically on grassland peat soils. His research focus has been on soil hydrology, soil water management, including land drainage, and soil organic carbon stock accounting. He's a member of the FACHA Joint Programming Initiative Scientific Advisory Board and an honorary professor at the University of Galway and visiting professor at the University of Sheffield. And he's leading several projects at a national and EU level on grassland peat soil. So over to you, Owen, and don't forget, everybody, please put your questions in the Q&A tab and give a thumbs up to those questions that you like.
Thanks, Carl. And can everyone see?
No, it's not full screen.
Slides?
No, it's still, now we can. Perfect. Over to you, Owen. Thanks.
Okay, perfect. Thanks, Carl. And thanks, Louis. I'm going to follow on and basically look at agricultural peatlands in Ireland. I'd also like to acknowledge my co-author, Pat Toohey. And like Louis, many, many other colleagues have contributed to the talk, and my acknowledgements will come at the end as well. So I'd like to, I suppose, this is largely a New Zealand audience, so I'm going to make you more familiar with what peatlands look like in Ireland. We've three recognised areas, really. The raised bogs of the Central Plain, or the Midlands in Ireland, that's right in the middle. The blanket bogs of the Western Seaboard and the upland regions. Some highlands as well have blanket bogs, and also the fen peats. And I'm going to show you some pictures of all of these and show you how they kind of associate with each other. Now, peatlands cover 1.6 million hectares in Ireland, which equates to about 20–25% of the total land area in Ireland. And that equates to about 62 or 75% of the soil organic carbon stock nationally. So same story here, a huge percentage of the total organic carbon stock. Now, if you look at the estimated peatland area cover, this is a diagram here by David Wilson, you can see that agriculture makes up 28% of this total pizza pie here, and therefore very, very important. Now, turn your attention to the map there. You can see that it's Habib and Connolly from Trinity College 2023. So we still have ongoing mapping activities going on in Ireland. So we get publications of a new map in 2023, but here we go again with Trinity Gillet et al. In 2024, and there's a new Irish peat soils map. And as of today, Dave O'Leary has got a paper accepted in Geoderma, which will come out early next year, looking at further refinement of peatland mapping using airborne radiometric peat soil mapping. So you'll hear a lot of numbers in this space, and these numbers are forever changing. It's something that you need to live with when you're in peatland research. So now, what are the agricultural peat soils used for? I'm going to use an example here from the Farm Peat project and Caroline Lawler in the Midlands. It's a big table, but all I want you to look at is it's low intensity farming we're looking at here. And you'll see dairy, tillage, sheep and beef. But of 51 farms on this project, 88 are in that sheep and beef area. Okay, so low intensity farming, small farms, and only about 41% of the farm area is peat soils. So there's a huge range of soils here in the transition, going from mineral, organomineral, which are those Louis mentioned them as well, shallow peat soils, and then into the deeper peat soils. So I'm going to go back in a time machine here to 1976. I love this diagram because it really looks at fens and raised bogs in their natural environment and in context with mineral soils as well. On the left there, you can see the mineral soils, then you go into the fen peats, and then you're moving into a little shovel there in the middle where, you know, there's cutaway by hand, then by machine, and into those big industrial cutaway areas that are used for energy and horticulture in the past. Now, if you look at a photograph of that, that really looks impressive on a landscape. you have these green fields, very similar to what Louis showed in terms of photos in New Zealand. But we're moving now across the transition, and you come into these cutaway areas and indeed into the industrial areas. Now, if you look at that picture there, I think it looks like a man with his arms out and his legs out. You can see there's an entire transition in that white box. And all of the farms that interact with that raised bogs is very interesting in terms of their drainage status, how the water table reacts underneath the soil. And there's a toing and a froing interaction here between the raised bog and those farms in terms of drainage status. We've lots of interesting projects looking at those dynamics. Now let's go into the raised bog, or the blanket bog, sorry, territory. This is still under 200 meters, so it's a highland bog in Kerry in the southwest of Ireland. And I'm standing on the mineral soil here, taking a photograph into a beautiful valley. There's 5 farmers and 5 farms in this valley, which we're looking at in another project. So your mineral transitioning into blanket bog across the valley. You're looking at that mineral soil again. There's forestry, there's, you know, wind energy going on here. A lot of activities within this valley. And to characterize these sites, you need huge teams of people to look at peat depths, to look at soil classification, and you need a lot of resources to cover landscapes this big. Here I am again standing on a mineral soil, and I'm just about to move into the transition. You can see the vegetation change here into the organic soils. Here I am now in front of the blanket bog. I'm standing in the grassland, and you can see 3 meters of blanket bog right in front of me like a wall. So these are beautiful landscapes, but in terms of hydrology, drainage, etc., highly complicated. Now let's look at the land use change and forestry, or LULUCF for short, projected emissions and removals from 2023 to 2032. You look at the graph here, and all I want you to look at is the zero, okay? There's bars above the zero and bars below. And the bars above zero, these are the countries with a net source of emissions. And of course, Ireland is one of these. And in Ireland, our net emissions are driven by forest harvesting, drained wetlands, and here is the drained grassland on peat again. And I'm going to focus on that a little bit more now. A lot of information in this slide, but it just shows the importance of numbers within the national inventory in Ireland or around the world, okay? So I want to take you back a little bit here. This is before April 2024. And here are the LULUCF categories, grassland, wetlands, etc. And here are the total emissions. It's like a league table of emissions. Where these come from are, you get 9 million tons lost from these deep drained peat grasslands, but you take 2 off, which is sequestered by mineral grassland. So grassland has a very, very high emission of over 7 million tons of CO2 equivalents. Now, an important thing to realize is that at Tier 1 reporting, the International Panel on Climate Change says if your water table level is unknown, it is all assumed to be deep drained, okay? And this then leads to this 26 tons per hectare multiplied by your area in Ireland, which is 336,000 hectares, and this comes up with this 9 million ton figure. But what's under the bonnet? You know, when you look at this 336,000 hectares, what is it made up of? So here's some figures. It's predominantly raised bog, then some blanket bog, and to a smaller extent, these fens. And these make up this drained peat soils on grassland. Now, Ireland has a climate action plan, of course, and there's one coming out in 2024, and it sets clear targets. So 2025, it looks to have 25,000 hectares of drained organic soils with reduced management intensity. And then into the future, by 2030, it wants to extend that to 80,000 hectares. Now, within that, there's loads of detail, but basically there's going to be 6 options here that, you know, define reduced management intensity. And 4 of these are about water table and about drainage, the drainage system, water table management in essence, okay? So it was a key question for us to ask, is the 336,000 hectares actually deep drained, okay? Can we assume that? And if not, the numbers need to be changed. And remember, for every hectare less than this, it means you're immediately taking emissions off the inventory. So it's very, very important. a group of us, Pat Toohey, myself, Lillian and Connor, we went off for a 2-year spell. We got lost in books and reports, old data from way back to the 50s, 60s, 70s, and all the way up. And we found that indeed, this 336,000 hectares, it certainly was not all deep drained, okay? We came up with a figure of 90,000 hectares that was actually deep drained, and 20,000 of that needs to be constantly redrained to maintain that stock. So that gave us a more, a more practical 1990 figure. Then myself and Pat went on and we got more evidence to bring that figure up to about 141,000. And that means that instead of that 336,000 hectare, we assume that only 141 hectare is deep drained. And this is the importance again of those numbers. So what does that mean really for the inventory? Now, we can't take all the credit here, obviously. There's lots of ongoing work all around the country on emission factors. We just looked at drainage status. But in the new inventory, which was brought out in March 2024, there was some huge adjustments made to the inventory. So you can see it went from 7 down to 2.48 for grassland. And that means that there's a big change in the LULUCF emissions right across the categories from 7.3 to just under 4 million tons of carbon dioxide. So what does this do? It allows us to have more targeted focus for research and policy. And now we can focus on 141,000 hectares, which is deep drained. Other activities around Ireland, very, very important here, the National Soil Carbon Observatory. Thanks to Rachel Murphy for providing this slide here. It shows that there's a huge army of eddy covariance towers now around the country, 20 on mineral soils, 8 on peat soils, and the data generated will provide accurate long-term information on the carbon dynamics of Irish agricultural systems. But the network covers different agricultural systems and land uses. And you can see here again, the land use covers peat cropland, it covers peatland rough grazed and peat grassland. So very, very interesting data is going to be coming out of this network over time. I'm not going to go into this slide too much. Louis really covered the Mapsters C. Just like to thank Julia Bondi for the slide here. But you can see again, eddy covariance towers used at a raised bog, fen and blanket bog site in Ireland. You can get really, really interesting information here and move things on to Tier 3 reporting. I'm going to dwell a little bit more on rewetting or water table management now. We have a rewet project. Pat Toohey is the PI of this project. And again, we've 12 deep drain peat soil sites and grassland all around Ireland. And we look at dip wells. We install dip wells that measure water table depth. And these are in fens and raised bog sites. And we also then block ditches and look at water table management. Here's a site at Garteen College. It's also a NASCO fen site. And we have amazing data. Here's data from Hilary Pierce, 15-minute resolution on water table. And you can see it now over 18 months where water table is shallow, water table comes to the surface, or in some cases, it's still deep drained. And this is giving us new insights on what kinds of sites we should be attempting to rewet into the future, and those sites that are going to be very, very difficult. So what's next? We have exciting projects at the moment, another Department of Agriculture and EPA funded project called DETECT. This will look at high resolution water table depth mapping at field, farm, and even national scales. It's even looking at machine learning and AI, drone satellite technology on how to do this at a very, very high resolution, but nationally. The Aspen project looks at high resolution greenhouse gas emission monitoring with Wen Shen-Shi here in our auto chamber setup in the Midlands. And this is with Matt Saunders and Carl Richards. But exciting for the future is, again, dwelling on what Louis mentioned with the Evans relationship between emissions and water table depth. If you use different technologies, you can cover ground across the landscape. And really, we are setting up living labs now in Ireland on peat soils. So you could envisage projects that bring DETECT together with high resolution greenhouse gas emission monitoring, and we can develop site-specific, country-specific regressions for the water table and how that drives emissions. So my take-home message is really grasslands and drained organic soils are a source of carbon. we need to have our numbers right. And our numbers are changing over time as we have more information, better technologies, for example, on peat soil areas and the drainage status. We need more data that reflects climate, soils, and management over time, and we need to develop water table depth and emission relationships for different scenarios. Ongoing research will further support targeted policy, and as Louis said, collaboration is key. And with that, I'd like to thank you very much for listening. Back to you, Carl.
Super. Thank you, Owen, and maybe you can stop sharing your screen and Louis can come back on. So look, there's a number of questions in the Q&A tab that we'll start to go through, but just a reminder for everybody, if you have a question, please put it into the Q&A tab and we'll get to it in due course. So Louis, there's a question there just in terms of looking for a bit of a definition clarification around peaty soils in New Zealand. So what is the definition in terms of the
Yeah, I saw that, and I rapidly emailed the guy who did that work to find out what that is. I'm afraid I don't have that answer at my fingertips, but we can come back to you on that, Lars.
And it may not just be a carbon content; it might be the depth of of that organic layer as well. I'm guessing.
Yeah, I think so. It might come in if it comes in. I'll let you know.
Right, Owen, from an Irish context, what's the definition of a peaty clay?
Yeah, I'll have a stab at this off the top of my head. I think, you know, if you break things up into histic soils, they'd probably have an organic content of over 20%. With a no horizon, probably have a thickness of over 7.5 centimeters, but up to about 40 centimeters. And then you start going into humic soils. These ones, I suppose, Carl kind of covered the organo-mineral type soils, and they contain an A horizon, so they're a bit different. And they have more organic matter than mineral matter, but they have a minimum thickness of 7.5 centimeters. And the organic content is lower than peat. We actually have a lot of those soils. I never mentioned it, but we do have an awful lot of those soils in Ireland. Like Louis was saying on the fringes, we have, I think, around 420,000 hectares of humic soils in comparison to 335,000 hectares of histic soils. So again, it's all about numbers, you know, and there's an awful lot of definitions flying about. And it's easy to get these things wrong, you know. I do feel sorry for both myself and Louis at times and everyone else interested in this area, you know.
Rather than getting things wrong, I say science evolves and we get a better constraint on the areas and the emissions. Go on, Louis.
So my colleague Jack Pronger just sent me through an email with a definition of the different soils, but I won't read it out. It is about 3 paragraphs long.
Okay.
I think Owen's quite right. It's quite challenging to get that right. Yeah.
And look, maybe you can put that. Could you type that answer into the response there to Lars? There's a little button you can press to type answer.
Well, it is very long.
So while you're doing that, then Owen, there's a question around: is there a county by county breakdown of the 141,000 hectares?
Yeah, look, brilliant question. So I would imagine there has been some analysis done by Raymond Feely in Teagasc. So going back to mapping by An Fearst Geluntas, more recent work on Irish Soil Information System. So I do know as part of the DETECT project that is going to be an output. So yes is the answer. So again, it goes back, Carl, to the targeted nature. You know, if we do know where raised bog, you know, fen, etc., they're the 2 main ones in terms of water table management. Certainly going to be easier. Yeah, sorry, go on.
Just because they were drained in the past doesn't mean they're still deeply drained. Yep. And I suppose that's what your project is trying to evaluate, is of those sites that were deep drained, you know, how many of them are still deep drained. Louis, there's a question there in relation to, given the flooding propensity of some of these areas, what kind of policy would you recommend for the future? I suppose that's for both Louis and Owen. What sort of policy might be considered for the future?
Yeah, I mean, I'm not the sort of person to talk about policy, really. I'm the scientist trying to figure out what we might be able to do about this. I suppose, you know, if it's flooding a lot, then you have decisions to make around how much pumping infrastructure you're going to put in place and how long that's going to be run for, and then who's going to kind of fund that through time. But you need to also remember that if you keep doing that, the emissions will continue as well. So it's about balancing those sorts of things, and then who pays for all of that? Either the pumping or the giving up of the land in a way in terms of its productive capacity.
And I suppose maybe you could comment on the policy development in Ireland in relation to peat soils. You mentioned a few things there in terms of targets and that.
Yeah, I think so I suppose my background would be hydrology, you know, where the water table goes, right? So I think the main part of my research that feeds into policy is if we're moving from tier 1 within the national inventory, which is very much like the back of an envelope, right? So it's what's the area of the soils, you know, what's the drainage status of the soils, what's the nutrient status of the soils? Can we give better numbers to those? So that's the first step to influence, I suppose, the inventory. But the more information you can give, like the question on the where are these soils, right? And per county basis, then maybe what we've been doing is trialing out some water table management on, you know, that fen versus raised bog. And what you find out very quickly is, you know, things aren't as easy or as straightforward in those kind of fen areas, right? They're very attached to the groundwater system. The water balance is quite difficult in those systems. So what I'm trying to say is that the more information and more targeted information we can give, maybe that's going to support policy decisions into the future. And you know, like Louis, all we can do, I suppose, is provide as much information for other people to make those decisions.
Okay, so question, well, it says for Louis, but I think it's really for both of you, which is what do you think the biggest barriers are to reducing management intensity on peatlands, as well as preventing further drainage? Are you seeing a greater approach to this in Ireland? So maybe Louis, you start on that.
Yeah, I think this is a great question. And this comes to, I had not realized how different, and I should have done, how different peats are around the globe and the way that they are used. In New Zealand, ours are very intensively used in comparison to what I've seen here in Ireland and also in Iceland, maybe less intensively than the vegetable cropping, say, in Switzerland. Now, the challenge then becomes that the land in New Zealand that is being used for this intensive dairying is probably more expensive, more valuable, if you like, than what is in Ireland. And so, you know, stopping practices, changing practices in New Zealand is going to possibly be more challenging than some parts of Ireland as well. Here in Ireland, I understand there are also subsidies for biodiversity and looking after those bogs, which we do not have in New Zealand. Having similar sorts of considerations in New Zealand and trying to understand how we would manage this land differently, which might have lower productive value, is the challenge. But having said that, you know, we're operating off very limited information. We're pretty sure the emissions are big. We don't know how big. And we really need to understand what those look like and whether we can reduce the size of them while maintaining some sort of production on those. I think one other thing, if I could, is that New Zealand peat bogs are very different than the Irish peat bogs in that in New Zealand, evaporation is greater than rainfall. That means that drains are important, but even if the drains weren't there, it would be difficult to bring the water table back up. And the reason that we have peat bogs in New Zealand is because the native vegetation that was there controlled the loss of water from those peats. It's really slowed it down to allow the water table to come up. So we have challenges in terms of what will we do with the land and who's going to pay for it? And then if we start making those decisions, where are we going to get the water from? And how do we maintain the water? I'm not saying this is impossible, but it is challenging. How do we bring that water table back up? And it's very different from Ireland.
Owen, do you want to make a comment in the Irish perspective in terms of, you know, what the biggest barriers might be
Yeah.
to reducing?
Yeah, it's a very good question. I think again, probably we're the early stages of water table management in Ireland, and it's largely a confidence thing, in my opinion. You know, we don't have an awful lot of sites that we can bring farmers to show them how it's done. Now, two great EIPs in the Midlands, Farm Carbon, Farm Peat, have been showing this, and we just need to show that we can control the water table management in areas. There's always a big fear that, you know, we have a project called Re-Wet, right? It almost like implies, you know, you're going to flood the land, but it's a very different definition. Water table management is way more subtle, right? And it's a lower management system. But we need to show people that where you do block a ditch and a drain, where's the hydrological influence? You know, does it extend, you know, 20, 30 meters? Can we control that? Okay. So that's very, very important. But I think the Re-Wet project will show that there are certain areas a lot more, you know, amenable to water table management. And like Louis said, it's in kind of those raised bog areas where poor drainage, water finds it very hard to escape. And these are probably areas that farmers would like to, you know, or consider retiring, as Louis calls it. I really like that term instead of you know, other terms that are being used.
So Owen, while there are technical challenges, I think you know, it's similar to New Zealand. While the intensity on our peat soils, some of them, is a lot lower than in New Zealand. We're not talking about intensive dairy in a lot of these, as you showed from the Midlands. You know, there's still the question of who's going to pay, and if it's acceptable to a farmer to retire their lands if the farmer doesn't want to retire their land. So it's that economic incentive, and I suppose, Louis, there is maybe a little bit of difference in between New Zealand and Ireland at an EU level. We see the introduction of carbon farming and the carbon farming framework. And one of the first areas that Europe is focusing on, which influences what's happening in Ireland, is peat soils and the rehabilitation and the, you know, there's the nature restoration also. There's quite a number of EU policies, but as you said, we do also then have incentives. But then, you know, the question would be, should the public keep paying that as a public incentive, or should be incentivized through the private sector? And that's, I suppose, working its way through the system at the moment.
One of the challenges there, Carl, is that we're talking about avoiding emissions of carbon rather than planting a forest. Correct. And that's kind of a tougher sell, you know.
Yeah, but it's switching off an emission source. So it's like reducing nitrous oxide emissions from soil or methane emissions from cows. It's actually hitting an emission source.
It's about thinking a little bit differently around soil carbon, because people tend to think about ways of increasing soil carbon. What we're trying to do here is protect what we have, and that's important. If I could just jump in there, Carl, I see my colleague Jack Pronger has answered the question on peaty glaze at the bottom of the comments there. So thanks for that, Jack. Quick work.
Thanks, Jack. A quick question then. Another follow-up was around, from Lars again, around your experience of eddy covariance versus manual chamber measurements in terms of the annual emissions. I'd say you could go and talk about that forever, but maybe at a very high level, Louis, what's your experience?
I've used chambers in the past in wetlands to look at methane emissions, and all of our focus really most recently for carbon balance work has been with eddy covariance. And for me, that's because of the scale at which it measures, hectare scales and annual kind of scales. And yes, it's technically challenging, but I really like the information that it gives you. You can integrate all of the imports and exports of carbon as well. So we have not done that much on chambers for carbon dioxide. Certainly nitrous oxide, you could consider methane as well, but we have very heavily leant in the past on eddy covariance.
I'm going to do a few quick fire questions at you guys now. Owen, any recommendations on managing the water table on agricultural land to minimize the impact on the surrounding areas?
Yeah, very, very good. It's like any drainage job, you start wide and then you start to focus your attention. So you never bund too much. You look, you bund and then you step back and you wait and see. It's the same principle as draining land as stopping up water. So for example, in 140 meter drainage ditch, you might have 6 locations where you're stopping water, but you don't put them all in at the same time.
Okay, Louis, can you break out CO2 versus the methane contribution to the emissions, assuming CO2 equivalent? So I suppose you did that at a national level. I think you said, was it 3 million tons came from CO2, and there was about maybe 500,000 tons from methane. I can't remember.
Yeah, I see that question's coming from Michael. I think he's in California, so greetings. The contribution of methane is about, I'm looking at this, I would guess less than 10% of the total greenhouse gas emissions from the peat, not including the animals. If you factor in the animals, and 3 cows per hectare produces a fair amount of methane, then that would be a bigger part. But just from the decomposition of the peat itself, it's maybe 15%. Oh no, it'd be 10.
And there's a stinger at the end of his question then, in relation to, would it not be better in view of climate change to dry the peatlands and grow corn as a high biomass rather than grassland? So maybe
I think you end up going backwards in the end, but because of the amount of CO2 that you would emit, yeah.
Exactly. You're talking like 20 to 30 tons of CO2 per hectare per year. Like, they're massive, massive amounts. And there's one here. Has there been any consideration of retiring land and restoring peat bogs and claim biodiversity credits and benefits, as well as carbon credits for avoided emissions?
Yep. Look, absolutely. It's one of the measures in place. I like the concept of retiring land. And thanks to Louis for introducing me to that. I think it's a different conversation. Now that the numbers are becoming clearer, it's a different conversation we're starting to have, right? It's not about these areas have to be re-wetted or water table managed. It's we're finding these areas that people, I think, would like to consider to retire. Okay, and that's a very, very different conversation. But it's because the numbers are becoming more targeted that we can do that.
So, when you mentioned, was it a European Innovation Programme or Environmental Innovation Programme in the Midlands? There was 2 projects around restoring peatlands and that. There's also, as part of the payment scheme from Department of Agriculture under acres, there is a peatlands payment based on a scorecard where if you have, I suppose, good biological indicators of having intact peats, that there's payments associated with those soils. So therefore an incentive for farmers to restore as well. Louis, another question here around what sort of activity data is there on drainage depth of New Zealand organic soils?
I think that's a really good question that I'm not sure that we have that good a data on. I know that Waikato Regional Council are interested in improving on that. I don't know about Southland, so I think that that's an area that we need more information on as well.
Okay, there was another question around the methane and CO2, and I suppose, look, what you highlighted, Louis and Owen as well, is the Evans paper, which was that trade-off, that sweet spot between reducing CO2 emissions and limiting methane emissions associated with re-wetting. Let me see, what else have we got here? So the issue of climate change and that, like, from your perspectives, what are the potential implications or impacts of climate change on the emissions from our drained peat soils?
Yep. So two big factors that are going to potentially change, right? Well, we know are going to change. Temperature is going to go up, and biological reaction rates increase with temperature exponentially. So a small shift in temperature will increase decomposition rates very quickly. So there's that. The other side of it is how wet the systems remain. There'll be some places that get drier and some places that get wetter. And where those changes occur will have impacts on existing wetlands and ones that have already been drained. If they get drier, then you can imagine that the water table will be lower. That could be a potential issue. Now, one of the neat things about New Zealand peat bogs, at least, is they are quite resilient to droughts, but that's in their native state. So if we can get them back to that state, we may be able to sort of manage our way through some climate change issues, but the temperature is going to be an issue.
Okay, thanks, Louis. Owen, any comments you'd like to make on the potential implications of changing climate?
Yeah, look, very similar to Louis. Our climate, we're getting more distribution of rainfall in our summer months, so it's changing the water balance, right? Very, very important for fens or water table management. And we're getting droughts as well. Okay, so up to 14, weeks without rainfall some years. So that's going to change. It's going to change the hydrology of the system, the hydraulic gradients, etc. And in terms of water table management, which actually is, quite a science in itself, that's going to be challenging into the future.
I suppose we had some evidence on the carbon observatory towers last year where one of them was nearly taken out by a peat fire. So, you might actually see an increasing propensity for peat fires as well as that surface layer dries out. There's a question here around re-wetting seems a no-brainer to reduce emissions and could start before the precise numbers are known. What work is happening in Ireland and New Zealand on re-wetting in combination with agriculture? And are you working with the Dutch who've been looking into this for decades? So Louis, you mentioned polluticulture. So is there stuff happening in either country?
So very early days yet. I mean, we're just starting to make a few measurements really in New Zealand peat soils. And so we don't have those kind of trials underway as yet. No, we have not worked directly with the Dutch. Dave Campbell did have a European-wide project looking at some of that, which I think did involve some people from the Netherlands. So there's a bit of that, but that work is finished.
Another one?
Yeah, always worked with the Dutch in terms of the drainage side. So most of the drainage theory comes from the Netherlands, and in turn, a lot of re-wetting research as well. We are involved in an Interreg project, so for Northwest Europe, and for carbon accounting and stuff like that. But a lot of our projects really we're actively re-wetting, right, and looking at water table management. The only polluticulture project that we're involved in would be with Green Restoration Ireland in the Midlands, where they have a farm where they're, trialing things like blueberries, etc. as well. And we are measuring water table. There's a NASCO tower at that location. So we're starting to dip our feet into those kinds of alternative systems. Yeah.
And really quick follow on. Are any findings on the blueberry polluticulture in New Zealand, Louis?
No, we haven't started that work yet.
Okay, that's fine. And look, I suppose final question. You both outlined the huge amount of works underway across both countries to I suppose refine our emissions and get a better idea of the areas that are drained and that. But like, from your perspectives, why is this so important to do this across different countries?
I have been struck by how different the peats are. Not only the climates that they were formed under, the vegetation that they have, and their uses. I'm just visiting 3 countries, Iceland, Switzerland, and Ireland. So different. And we need to know what these relationships look like in each of these different countries. Similar kind of biogeochemistry, but the setup and their responses do differ enormously.
Yeah, I agree. And the hydrology of them are very, very complicated. That's the key one. We can really learn from that. In the water phase, remember, Louis mentioned it earlier, DOC, like the water phase is really important for the carbon balance as well, and how we can manipulate it we were very successful at draining land, and now we have to figure out how to put stoppers in the right place to hold the water back up, yeah.
Okay, guys, thanks a million. It's 10 o'clock in Ireland, and it's probably, I think, 11 in the morning in New Zealand, I think. So thank you both for really fascinating talks, and thank everybody in the audience for their interesting questions. Apologies if I didn't get to them. I was trying my best, but it's hard to keep your eye on the questions and keep the discussions going. But look, thanks everybody, and have a good day and have a good night. Thank you all.